I sometimes find myself thinking about planetary cores, these incredible, inaccessible engines hidden deep inside a planet.
Right.
We can really only guess how those metallic hearts formed.
Yeah.
But what if we could actually visit one?
And that's basically what 16 Psyche is.
Exactly. It's a journey to a metallic world, a giant exposed building block of a planet just floating out there in the main asteroid belt.
And that's what we're digging into today. We're looking at 16 Psyche, which is the largest of what we call the M-type asteroids, the M standing for metallic, of course.
Of course.
And we're also looking at the NASA mission that's designed to solve its perplexing composition. Psyche just does not behave like the textbook core we expect it to.
Okay, so let's unpack that a bit. Psyche was first spotted way back in 1852.
A long time ago.
Yeah. And it's huge. It's about 220 kilometers across and holds about 1% of the entire mass of the asteroid belt.
1%. That's incredible.
It is. I also love that its original astronomical symbol was a butterfly's wing, for Psyche, the Greek word for soul.
But that's where the puzzle really begins, right? In the physics. This is where it gets fascinating because of its density.
Right.
Its bulk density is calculated at about 3.977 grams per cubic centimeter. Now, for comparison, a pure iron-nickel core, which is what we first thought it was, would be closer to 7.9.
So it's about half what it should be.
Exactly. And the implication is just staggering. I mean, if Psyche were a pure core, it would have to be 50% porous, just riddled with voids.
50%. That seems, impossible for something that size.
It's considered highly, highly improbable, yeah. That density deficit just throws everything into doubt.
So, okay, our source suggests that other kinds of metal-rich materials might fit that density a lot better. What are we talking about here?
We're talking about things like mesositerites, those stony iron meteorites, or maybe enstatite chondrites, which are silicates that formed under really dry conditions.
Okay, so dry conditions, but then there's another twist, isn't there?
There is. And just when you think you've narrowed it down to these dry, hot-formed materials, observers detected hydroxyl ions on Psyche's surface.
Which means water.
Evidence of hydrated silicates, yeah. So this moisture points to past impacts from smaller, water-bearing asteroids. The thing has a messy history. It's not just some pristine, stripped core.
And figuring out that messy history is the whole point of the mission. But before we get to the spacecraft itself, we do want to mention our sponsor.
If you need help turning complex data into actionable plans, whether that's software development, AI training, or just figuring out where agents could make the most impact for your business, check out embersilk.com for your AI needs. This deep dive is sponsored by Embersilk.
All right, so let's talk about the spacecraft. The NASA Psyche spacecraft is, it's a pioneer. It's the first mission to ever explore a metallic asteroid.
It is. It launched on October 13th, 2023, and it's on its way.
And if everything goes according to plan, it gets there in 2029.
That's the plan. And this mission, it's fundamentally about testing these competing origin ideas. The classic theory that it's an exposed core of a bigger protoplanet that's largely been discarded now because of that density problem.
So what are the big theories left on the table?
Well, there are two main ones. The first is that Psyche is a gravitationally re-accreted mix of metal and silicate. Basically, it was shattered and then pulled itself back together. And the second, and this one is pretty wild, is that it's a differentiated object that actually experienced something called ferrovulcanism.
Ferrovulcanism, you mean iron volcanism?
Iron volcanism. Liquid iron erupting onto the surface while it was cooling. And, recent radar observations actually seem to bolster that idea.
So this mission will finally tell us which of these violent origin stories is the right one.
Precisely. This isn't just about a distant rock. It's about studying a foundational building block of how planets like ours are made.
So when you boil it all down, what does this actually mean for us? This mission gives us a really unprecedented glimpse into the processes that form the very hearts of rocky worlds.
Yeah. And here's a thought to leave you with. If the data confirms that Psyche is the result of ferrovolcanism, of these liquid metal eruptions, and not just a stripped core, how fundamentally does that change our entire understanding of how planets form in the early solar system?
A fantastic thought to end on. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.